Good morning, guys. So could you please turn on the camera? Let me know your face. Morning. And to start with, I would like to check the attendance first of all. 1, 2.
I don't have my camera in the computer.
So
I can't turn on my camera.
You have to solve.
Uh,
It's no reason. I just give you enough time to prepare.
can I use my phone to?
Yeah. Number 1, number 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13. 13.
Yes.
You're here?
Yes.
I cannot find you because it is the naming is not aligned. So I need to double check. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. Okay. All right. All of you are here. So welcome all of you to come back to the IS lesson again. Now to start with, I've just given you the notes for today in the chat box. Okay, please download it now. It's in your chat box. Take a look. Can you find it? This is set as page 23 to 28. Do you find it? Okay, response please. Do you find it?
Yes.
Yeah, thank you. So please click it. And this is what I would like to have it today. The content of it, they are more or less the same as the book, but I change a little bit in terms of a logical thoughts. And I would like to.
Chin, I don't see the worksheet thing.
In your chat box, take a look. Have you downloaded the notes first of all?
I don't see it.
In the screen, you may find this, and in the chat box, you should have the soft copy. Do you find it?
No.
No. In your chat box.
I think because we entered late,
okay.
So.
It doesn't matter because in your chat box there should be one. What do you see in the chat box? Nothing.
Nothing.
Nothing. I don't see anything either.
Oh, I see.
I can't see anything. Also.
Now I would like to send it again because all those that have been received. It again. Do you find it again? I've just resent a file. Did you receive it?
No.
Not yet.
No.
I still can't see it.
I think it's the problem of the iPad. I think.
iPad, you don't have it.
我覺得應該係用電腦開先至手。
Anyone who have now, I don't know whether or not that there is some technical issues and anyway, do you have a class WhatsApp? Class WhatsApp, do you have it? Anyone who have got my phone number, okay, could you please send a hi to me in your class? I don't know who is giving my phone number. No? Anyone who has got my phone number? I try to send this to you as such as you can use it and retrieve it in your class WhatsApp. Who? Who has got my number? No?
Yes, I have.
Yep. Okay, just say hi to me. And I just send that file to you right away. Now, for those who are using the notebook version, you should have got that. now, yep, I see one student, Bunsen, has said hello to me. Just send his file. And after today's lesson, I would prefer you to open a group for IS. Okay, who is the subject monitor? Who is the subject monitor?
Here.
Who are you?
Number 7.
Number 7. Could you please open that after today's lesson, and such that we can share some important information. Thank you. Now, I will give you 1 more minute to download it, and we'd like to start it right away. Yeah, this is the page. Yeah. And today's task is to take a further look on your, I'll give you 1 more minute before we start, okay? Just wait. Okay, do you find it? All right, let's start. Now, and today our topic is on compounds and mixture, but the way to classify them is a little bit embarrassing because they are in different category. So this is the diagram I just showed you. I just wrote it on the blackboard 2 weeks ago. So to start with, could you please fill them in the blanks for me? Okay. So indeed, matter can be classified into different things, just like what we have in the last lesson. We tend to have it. We tend to have it pure. Okay. We tend to have it pure because for each pure substance they have their own use. Okay, so we will call it pure substance. But very often in the world, we would have the raw materials just like air, ocean, rocks, okay, etc. And all those it is just impure substance. Okay, or you use the word mixture to tell. Okay, do you see my wordings? Okay, so I try to use the words things, right? And if you want to make a difference between them, is by this. Okay, if you directly mix the pure substance, will have got mixture. But while you have got the mixture, you want to separate back into pure substance, you may use the word physical method. So can you give me some example physical method? Now, for example, I would like to have seawater or maybe salt water or salt solution. How can we turn back to salt and water? How?
Heat.
Heat? Some technical way. Some technical
Evaporation.
Sorry? What separation?
Evaporation.
Once you evaporate, what will be evaporated?
Some water vapor and salt.
Or water will be evaporated. How about salt? Will you still get salt? Now, if water has all been evaporated, you may get salt, right? How about water? If we want to collect water as well, evaporation.
Distillation.
Yep, very good. Distillation. Have you ever heard of this term before? Okay, distillation. What is that? This is what you know it in what?
蒸餾.
Yes, 蒸餾法. It is in form 1. What you know in form 1. Okay, so this is what we call it as a physical method. Why is this called a physical method? Is it in between the steps? There are no chemical change is involved. Okay, no chemical change is involved. For distillation, it is simply a type of what we call it as a change in physical state. Okay, it's just a change in physical state. Tell me, what is that? What is the change in physical state? Tell me.
The change in physical state, it went from solid to gas. Oh wait, liquid to gas.
Liquid to gas. Okay, so that only one substance undergo change in physical state. What is that? Salt or water?
Water.
Water. Okay, but it is something difficult to you because it is just like boiling and condensation. Now, these two terms should appear in your form 1, right? That two terms, you want to make it more specific. Instead, in terms of just telling me from liquid to gas, let gas go back to liquid. There are some technical terms. Okay. It seems that your class have already those form 1 IS. It's time to go back to have a recap more on these terms. Do you still remember those terms? Yeah. Okay. Boiling, condensation, etc. So and then if you have got pure substance, we have got two types. Okay, we have got two types of pure substance. Okay, one of them we call it as what? We see the word chemical decomposition and chemical combination. Which is which? Now I'll give you two terms. One is element. Element is a pure substance. Can you see that? That cannot be split up into anything simpler by chemical method. Okay, cannot be split into simpler by chemical method. A substance only contain how many type of atom? We got it one type.
One.
Yeah, just one type. It's the same that you know it in the very first lesson. So this is what we call it as element. As element. Now, so this is what I expect you guys should know about in the Earth crust. Okay, in the Earth crust. So that means on the surface of the rock on the Earth. Okay, what is the most abundant element? Do you know it? What is the most abundant element? Most abundant. Do you know what is the term? Most abundant. Okay, most abundant, which means it contains the most amount. Which one?
Oxygen, silicon, and aluminium.
Yep. So oxygen is the most abundant element, and then for the most abundant metal, it is aluminium. Okay, but not for iron. Iron rank number 2. But you may find that according to the price, iron is cheaper, right? So there must be something behind, some reason behind, and it is related to the cost of extraction. Cost of extraction, 提煉方法. So this is because these two is different. But what you may see is that oxygen comprises the most of the part of the substance in the world. But remember, I just want to tell you the ranking according to elements. So do you mean that those materials would exist free as element? That is another case. Okay, so among that 118 elements, they are not just sticking into the ground or be collected from air, and that is already element. Okay, they are not in that form. We will have it in compound form. Okay, only very few elements they will exist in pure and uncombined form. Most of the time, you are having as a compound form, and also it is impure. So you need purification method to collect those elements. Okay, so you see that chemically extracted. Okay, which means that you need some chemical method to get it. So in short, we will call this type of substance a compound. So compound is a pure substance that are made up of two or more elements chemically combined together. So underline the term chemically. Okay, chemically combined, which means that we are going to have a super glue. In chemistry, we call it bond, and try to make it together. For example, water is a compound. It's because the hydrogen and oxygen atom, they're connected to the ratio 2:1. So you may use that diagram for help, right? I just write it Mickey Mouse for many times. So you may know that the small ball represent hydrogen atom, and this is an oxygen atom. So similarly, or if you want to talk about CO2, so we'll have got carbon and oxygen atom respectively with the ratio 1:2. Okay, so and this is what theoretically it is combined by having hydrogen gas and oxygen gas to form water, like this. Okay, we got hydrogen gas and oxygen gas, and you combine it like this. So what is meant by chemical combination? Very often it is presented in terms of an arrow here. All of you please mark it out, the arrow. The arrow, it is what we call it as a chemical reaction. We call that it is a type of chemical reaction. Do you know it in Chinese? 化學反應. 化學反應. Okay, so similarly, for carbon dioxide, how is it formed? How can it be chemically combined? How? Vũ Trọng Phái. How can we get carbon dioxide?
Two oxygen and one carbon join together.
Oxygen gas and what combined together? What?
Carbon.
Carbon, yeah. So how can it be done? How can it be done in practice? How? Now, just like hydrogen gas, oxygen gas, how can we combine to water? How? How about carbon dioxide?
Chemical reaction.
Chemical reaction. How? Exactly how? Can you you'll be given some hydrogen gas and oxygen gas, for example. How can we produce water? How? In the experiment. Just imagine you are in the lab and you're going to do that experiment. How will you do it? Can you get my point? How? For example, you'll be given one test tube of hydrogen gas. I've got one tube of oxygen gas. We've got the two. So you're going to produce water. How? Anyone who want to have a try? But Gongsun, you just inverted yourself. So funny, right? You just inverted yourself. Okay, I have to look at it as 180 degrees, to look at your face. Can I have another guy to tell me how to see it?
Yes.
You'll be given a bottle of hydrogen gas, a bottle of oxygen gas. How can you produce water? How? No. No idea.
Yes. No.
You have done that before. Now, do you know the nature? What is the use of hydrogen gas in our daily life?
Balloon, hydrogen balloon.
Hydrogen balloon again. I just said to you that we will not use hydrogen gas because of what?
Rocket.
Yes, rocket what? Rocket what? The whole body as a rocket? Which part?
The fuel.
So how can we make use of the fuel? No idea.
Burn.
Yes, burn it. So simply, the answer is burn it. Okay, and supply some energy. So hydrogen, oxygen gas, they would start to recombine to form water. And similarly for carbon dioxide, I burn carbon. Can you get my point? I burn carbon. While you do this, this is what you know how to form a compound. Okay, how to form a compound. Another example is sugar. Sugar, it is a type of sucrose. We call it 蔗糖. So it is a compound made up of carbon, hydrogen, and oxygen. Have you ever heard of the term carbohydrates? Carbohydrates. Have you ever heard of this term? 碳水化合物. Have you ever heard of that term? So what does it mean by that? Inside that we have got something we call that carbon, and we have got something which contains water. Okay, but of course, water is also a name of compound. What do I tell you is that the combination is very strange. Okay, with hydrogen and oxygen in the ratio 2:1, very similar to water. Okay, get my point. So we call that carbohydrates. So you may see this. Can you write for me those different compounds here? What makes that? For example, glass cleaner. Okay, 玻璃水. So you need ammonia. That is
neon and hydrogen.
Hydrogen and
nitrogen.
Yeah, nitrogen and hydrogen. And could you please finish the remaining parts? Do it now, and then tell me what are those. How about Lampaka, table salts? Yeah, table salt.
Nitrogen, no, the sodium and the chlorine.
Yep, sodium and chlorine, but the naming system is quite strange. We call it chloride, okay? The whole thing we call it chloride. But if you split it into two, we call it sodium and chlorine. Thank you. Water, as said, it is easy. It is hydrogen and oxygen. How about drain cleanser? Drain cleanser, the one you use it in kitchen. So it is different from
sodium, oxygen, and hydrogen.
Yep, sodium,
oxygen, hydrogen,
and hydrogen. So it is in terms of an alkali. Okay, alkali gas. It is used in kitchen pipe. Why? Because it helps to react with what? Do you know? Oil, grease, and oil. I use something alkaline. I can clean that easily. How about table sugar? As said before, carbon, hydrogen, and
oxygen.
So how about last one? Baking soda. Okay, so sodium,
hydrogen, carbon, oxygen.
Yep. So we have got 4 different elements: sodium, hydrogen, carbon, and oxygen. So the naming system is we go with the chemical name, chemical formula. So once you may find that as task is easy simply because of what? You may find the chemical formula, right? If you see the chemical formula, you can tell the constituent elements so easily. But without them, can you tell? A little bit different, right? A little bit difficult to some of you. So what you may see about the compound is that it seems they will be given a formula. So what's more about the formula, they will give you a very fixed ratio of a forming elements. Okay, to tell you what is the ratio of those atoms that help combined to form that substance. Can you get my point? It'll give you a fixed ratio. For example, water, 2 hydrogen, 1 oxygen. Carbon dioxide, 1 carbon, 2 oxygen. Okay, but of course, if I change the ratio like this, carbon monoxide. So what does it mean by that? It's somewhat toxic, right? 一氧化碳. So how will you get what carbon monoxide? We come what? 1 oxygen and 1 carbon.
And 1 carbon.
Yep, so can you get my point? So that two is different things. How do you know that it's different? The right-hand side is toxic. The left-hand side, carbon dioxide is not toxic. Okay, second, greenhouse gas, you know it. The left-hand side is a greenhouse gas, the right-hand side is not. What else? What else? Can it be burned? Carbon dioxide cannot be burned, but carbon monoxide can. Okay? Carbon monoxide can burn. So that's why, and it is also one of the chemical components found in town gas. You know it? What's meant by town gas? 煤氣. So why can it be burned? It's because we have got hydrogen gas and carbon monoxide, and both can be burned. So that's why if you say that somebody commit suicide at home, right? They will turn on the town gas. You know it, because carbon monoxide is toxic to you. So never do it again. This is what I tell you. Chemistry is not used like this way, okay? Can you get my point?
Yes.
Good. So I would just have it here right away. Any questions so far? We've got half an hour more. I just stop it for a while. And any questions so far? I will not turn on the. I will not turn off the video because I've picked the version. Well, we will continue the class. Any questions so far before we continue? I give you 1 minute break. Any questions? You may ask some questions in English, or somebody who want to ask it in Cantonese, you can. But you may also make use of the chat box to ask. 有咩問？
如果將啲 hydrogen 同啲 oxygen 擺埋一齊嘅話咧，係咪要燒過佢？要加熱咗佢先會變成水嘅
？What do you think？係咪㗎？ So indeed, you just refer to the case while you are having the cooking at kitchen, right? You turn on the town gas. So would it produce a fire? No. I need something. I need some energy supply. For example, a spark. Okay, I need a spark. 一個電嘅火花啦， or you use a fire. Okay, you can. And for formation of compound from its elements, it depends on the different materials. For some materials, they will easily combine without any help. For example, last time, do you still remember we have got sodium, right? A very soft metal. I cut it into a spectra and can cut it into half, right? For that piece of material, once I place it in the air, it can already react. No need to supply heat. Okay, so this is one case. But we have got some other cases, like for formation of water from hydrogen gas and oxygen gas, you may need a spark. Similarly, if you have carbon dioxide, you also need some energy to supply to start the reaction. Okay, it really depends. It really depends on the chemical. Okay, it's not necessary to be the case I need heat. But for some chemicals, we don't need heated, and the reaction will go by itself. Okay, any questions? Any questions? 仲冇其他問題 ？No. Oh, wait for me because I need to click something on the web. Something funny. From 4. Oh, just wait for me. Sorry about that. Okay, I will start it after 1 minute. While you're waiting, could you please finish that tube? Could you please tell me what it is on this page? Okay. What is that? Yeah. Any word that you don't know?
Combination. Sorry. Combine.
What is that?
Element and compound.
You mean compound, is it? Or combine?
Yes,
combine. What thing are you referring to? Compound. Right? So compound, what is that? It is somewhat very special. Inside that we have got their own components, okay, to make that compound. So for example, water is a compound, carbon dioxide is a compound, carbon monoxide is a compound, table salt, okay, is also a compound. So inside that, what can you get? We have got 2 or more types of elements, okay, 2 or more types of elements, and we need some chemical combination to make that compound. Okay, 有啲化學嘅結合啊。So it depends on the way to produce that. For example, if I have got sodium chloride, I can easily do it like this. Now, let me show the video. Let me see. Now, for example, now if you search it on web, you may see what I want to say. Sodium, chlorine, sodium chloride. Yeah, you may find that. Do you see it? Do you see it? So this is what you may know it. How can we produce the table salt? You may take a look on that. Let me know if you can.
In this demonstration, I am going to attempt to make sodium chloride. A very cool reaction, one of my favorites, as I always like to say. But in order to make sodium chloride from its elements, I'm going to start with elemental sodium, which I have here, a very sulf-reactive metal that is stored in kerosene, because the kerosene being non-polar is...
Now, the sodium is found on the right-hand side. Can you see that? So it can be cut into a knife, and except it is stored in somewhere, stored in what? 聽唔聽到啊？先 kerosene is that? What is kerosene? Kerosene is 火水 of organic substances, 有機嘅溶劑 okay, organic solvent, and it does not mix with water, just like paraffin oil.
Is hydrophobic, prevents the water from reacting with it, as we've seen in other demonstrations, or mine. And I'm going to generate the chlorine gas, the chlorine atoms, okay, from potassium permanganate with hydrochloric acid. So the potassium permanganate, being a strong oxidizer, okay, is going to make the chlorine atoms become into chlorine atoms, chlorine ions. And from the hydrochloric acid I'm going to add to the potassium permanganate is going to become the chlorine gas here. And you know the chlorine gas is present when you see a yellowish green. There's a little bit here that I've made previously, but I'm going to pump it up, or pump up the volume, so to speak, with some acid or hydrochloric acid. So it's the chloride ions reacting with the permanganate ions, and the chloride ions being Cl negative are going to lose the electron, okay, be forced to oxidize by the presence of the oxidizing agent, the potassium permanganate.
Now, what is it now doing to do? They have one chemical, we call it potassium permanganate. Don't worry about the chemical name. And then they would like to add acid to it to produce chlorine. Okay, I just give that, and you will see what will happen. They just mentioned what is the color of chlorine gas. What is the color of chlorine gas?
Yellow green.
Yeah, yellow green. So once you add it, and will produce chlorine like this. Can you see that? We've got some chlorine, and what's next is to let them react.
Drop it, hopefully, right in the middle. Okay, reposition my camera a little bit. Okay, now
sodium inside.
Let's see if we get a nice little close-up here. What's going on? And refocus. And what we're going to do is I'm going to drop some water on this sodium metal to activate it. And we should see a pretty brilliant reaction once I activate it. So I'm just trying to drop some water with a pipette to start the reaction. And
do you see what happened?
There it is. And that white smoke you see is sodium chloride solid. It's a colloid. And so that white smoke is the presence of sodium chloride that we made.
So do you see that we are going to start the reaction by adding some water to it, but we focus on what? We focus on the heating. Do we need to have any heating? No. Okay, the making process it just goes by its own. So now in short, what do we have is that we have got sodium, which is sulphuric, and we have just chlorine, but in this internal gas is Cl2, it is greenish yellow. So after the combination, we have got sodium chloride as a product. Okay, while these two, we call that reactant. We have got a chemical change, or we'll call it chemical reaction, a chemical change. They will form a product and sodium chloride, but what is that color? Is in terms of a white solid. Can you get my point? So you may see the difference between them. Sodium, chlorine, they will have their own property, while for the compound, it has another new property. Okay, it is in terms of a white solid. Can you get what I mean? So we will call this type of reaction a chemical change. So can we go back in reverse? Can we go back in reverse? Can we have a compound? And as said before, compound is made up of two or more elements chemically combined. So can we separate it? Can we separate that? Can we do so? The answer is yes. How? We need some energy to make it happen. Okay, so I would like to show you another video.
And as it dissipates,
it is by, for example, if you take a look on the book, take a look on the book. So I would like to show you this one. Electrolysis of water as example. Do you find it? Now this time, I would like to show you here. You can also do it at home, but be careful.
In that small plastic container are two metal pins, and they're inserted a distance that's between the positive and negative lead of the 9-volt battery. So you just insert them in there and make sure that they're that distance apart, and that should be fine. In the container is going to be some water that has baking soda mixed into it. The baking soda in the water allows electricity to flow between the two metal tips of the push pins. And so now you set them on the leads, and the electricity can flow between the two push pins now, and so electricity is flowing through the water, and so that's enough energy to break apart the water, make it undergo a chemical reaction, so that the H2O gets broken apart into H2 and O2. It's going to be hydrogen gas and oxygen gas, and both gases are going to flow up through the test tubes, and one of the gases is going to be in one test tube and the other one's going to be in the other one. How do you know which one's which? Well, if you take a look at the amount of gas in each test tube, there's going to be twice as much hydrogen gas as oxygen gas. So you can see in the right test tube, you have twice as much hydrogen gas as oxygen gas. This is how experimenters first learn that the ratio of hydrogen atoms to oxygen atoms in water is 2 to 1. It's 2 to 1 ratio, thus H2O.
Now, of course, for a little while, now take a look on the setup for this part, okay? Which one is hydrogen? Which one is oxygen?
The right is oxygen.
The right one
hydrogen,
is
hydrogen.
Hydrogen, okay? This one is hydrogen. And this one is oxygen. To a ratio, can you see the ratio? Ratio. One parts, okay? One part of that, okay? It is 2 to 1. Okay, you get my point. It's 2 portions, and while this one is 1 portion, and we will get H2O. Okay, so indeed, what is now doing, we have got an electrolysis setup. But of course, what do we need? What do we need? A battery, okay? We've got a battery, a 9-volt battery can help. Okay, a 9-volt battery. So based on these two, can you tell me which one is positive, which is negative? Do you recognize which one is positive, which one is negative? You don't know. This one is positive. The right-hand side is positive, the other one is negative. And second, from the volume of the gas, you may know that it is hydrogen on the finally on here, oxygen finally on here. Okay, but the water itself cannot conduct electricity even in 9 volt. I add something to it. Do you know what is added?
Sodium chloride.
Sodium chloride. Really? Sodium chloride, yes, that's right. And also, you may also add acid to it, some acid. According to the book, you may use dilute sulfuric acid, 硫酸, and it can help what? Increase the electrical conductivity to make it conduct electricity better. Okay? Can you get my point? So finally, you'll be going to take a look on the book. Do now take a look on the book and turn to page 25. Take a look on the page 25. We try to finish the blanks and try to imagine a scenario. What will happen while you are having the chemical reactions? Indeed, I add water and do one important process. We call that electrolysis. Electricity. Lysis means breaking down. In Chinese, 電解. Okay, so breaking down. Breaking down of what? Breaking down of the water to form elements. Okay, do you understand? So take a look on the in the book now. Page 23. Could you please answer that? I'll give you 2 minutes and try to finish the findings. 2分鐘，望望睇下識唔識寫。 Can you see the PowerPoint here? Now, indeed, electrolysis means you are going to pass through the electricity to break down something. Okay, this time I break down water. And in the secondary school lab, we will have the setup we call the Hoffman voltameter. Okay, well, you take a look on electrode A and B, whether no matter it is positive or negative pole, they also give you colorless gas. But I don't know whether or not it's hydrogen and oxygen gas, right? So like this, okay? So what you need to do is to measure the volume to tell, and also you are going to give you a test. Except before, underline, increase electrical conductivity. I add acid. I also can add sprinkle some salt to it. Allow the setup to run for 10 minutes. Collect the gas in the graduated chips A and B as using separate tester. And you're going to test the gas in graduated chip A with a glowing splint. What do you observe? A, what is that? A, is it oxygen gas or hydrogen gas? If that is the case, oxygen. Oxygen, yeah, oxygen. Only that gas can be like a glowing splint. How about B, burning splint? So what will the observation? How will test it? It will give you what? Zhang Dalang.
Yes.
Yep. What do we observe? If I put a burning splint into the...
We set the fire.
Oh, pull off the fire?
Yes, I think.
Pop sound. Somebody say pop sound. Now, it depends on the burning splint. Now, remember, it's very often that somebody will think that the fire will pull off. It depends on position, where you put the burning splint. If I put it here, hydrogen gas is here, oxygen in air is found here. We've got this, we've got this, we've got heat. So what will happen? Just recall your memory in Form 1 IS. What is that? Forgot. Fuel. Oxygen. What is that? Fire triangle. So the fire will burn, right? It will burn more vigorously. So we have got explosion to form water. So indeed, pop sound test, it is the chemical reaction to produce water. The same case, okay? But I want to make it as a controlled explosion. Can you get my point? So if you put this burning splint just directly inside the inside of the tube, no pop sound. Do you know why? Because no oxygen inside. Can you get my point? So of course, no oxygen. What will happen if here, on here, no oxygen? Of course, no fire. So remember, it's a matter of technique that you need to be aware. Can you get my point? It gives a pump sound. Remember, you put it near the mouth of the tester instead of putting inside. If you directly put it inside, sorry, they will give you a false negative result. Do you know what is the meaning of word false negative result? 呢句說話咩意思啊？呢個 false negative 假陰性。Hey, come on. Nowadays, while you are having COVID-19, you know it, right? What does it mean by false negative result? Indeed. So what do you know the meaning? The test should give you positive result, but the results gives you negative, and you think that it's negative, but it's wrong. So we call it false negative. Can you get my point? So do we have some cases like false positive result? The answer is yes. A matter of the design. It is a matter of design of the experiments. It will give you that false information. Okay, it's very funny, right? Now you may know that too. Okay, you may know that too. So my focusing point is on the last part. Do you think that based on result, what elements is water made up of is oxygen and hydrogen, but the gas cannot be further broken down. Okay, they are elements already, so they cannot be broken down further. Remember, they cannot be broken down further. So this is what you may know about the difference between compound and elements. They want to go back to elements. Okay, is that clear? Is that clear? So I would like to show you another video as a final part before we end up the lecture today. And it is something about the testing of the properties of the compound when you compare with elements, and also we will see it in mixture. Do you finish? Copy it? Finish? Have you all finished copying this part?
Yes.
Yep. So I would like to show you another one. This is the one.
Hi Year 8s, this lesson we're looking at an example of elements, mixtures and compounds. So I've got some iron represented by the black molymods. Okay, so that's my element of iron, and I've got some red molymods to represent the sulphur. Okay, so iron is a metal, so there's fine iron filings there, and sulphur is a non-metal and it's this yellow powder. So if I took some sulphur and I mixed it with the iron to give us a mixture of iron and sulphur, okay, would it be possible to separate the iron from the sulphur? And if so, what method could we use? Okay.
Do you know what method can we use? If I want to make an iron sulphur mixture, I want to separate again. So
use magnet.
Magnet? How? How?
The magnet will attract the iron powder and will separate.
How about, would it be any attraction towards the sulfur powder by the magnet?
No.
Oh, because sulfur is not a magnetic substance, okay?
So the simplest thing to do would be to use a magnet. So I can take a bar magnet and I can wave that over the iron and sulphur mixture, and the bar magnet will attract the iron and separate it from the sulphur. So because iron and sulphur have just been mixed together.
So what is that method? Is it a chemical method or physical method?
Physical method.
It's physical method. Okay, because no chemical change will occur. How we know there is no chemical change? The iron powder is still gray. The sulfur powder is still yellow. Once I separate it again, it's still yellow, gray is still gray. Okay, so no change in its chemicals.
It's quite easy to separate out, okay, the iron from the sulphur. Right, so if we look at the molymods, all we've really done is got the iron and the sulphur to mix together, and they're not chemically jointed anyway, which means it's quite simple to separate them, okay? So what could we do to make the iron and sulphur chemically joined together? So to get a chemical reaction to happen between iron and sulphur, what would I need to do? Right, so that's my second experiment. So here I've got iron and sulphur in a boiling tube and I'm heating it strongly. So by heating the iron and sulphur, I'm causing a chemical reaction to happen, and that's going to make iron sulphide, and that's my compound, okay? So there's some sulphur, just a little bit of sulphur left around the boiling tube, okay? And it's starting to heat up and it should start to make some iron sulphide. And I've got some that I produced earlier. So here's some iron sulphide at the bottom of this boiling tube. And if I get some of this out, okay, we can see that we've now got iron sulphide. Okay, so that's iron sulphide. It looks nothing like the iron and sulphur mixture. Okay, and if we tried to separate the iron from the sulphur, that's not really going to happen. So even if we use a bar magnet, because they're chemically joined together now, and we've now got a compound of iron sulphide, it's not possible to separate the iron from the sulphur. Okay, so we've gone from an element of iron and sulphur to a mixture of iron and sulphur, and now a compound of iron sulphide.
All right, so you may find this is the chemical reactions about the production of iron sulphide, a very authentic experiment. Okay, a very authentic one. So you take a look on the second one. The second reactions is about you're going to test the properties of the three. Indeed, we comes to elements, mixture, and compound altogether. You may find it very confusing. Okay, for example, sulfur powder and iron filings, which means iron powder, they are just elements. Okay, once sulfur will not be get attracted to magnet, but for iron, yes. But next we are going to heat the mixture together and try to see whether or not they would be further attracted to the bar magnet. Now, of course, the answer, it will be a little bit different while you do it in the lab or while you see in the YouTube, that it seems that the compound will also be attracted to the bar magnet, okay? So, but from the appearance, you may find that something new has been found. It's no longer part of them yellow, part of them is gray. It's the whole thing is black. Its whole thing is black. Okay, so instead of yellowish gray, it is just an individual chemical that mixed together. I produce something we call it iron sulphide, which is a black material. So by doing so, you may have that idea about the properties, at least from the appearance, that they are different from those of the sulfur and the iron, which are the constituent elements. Okay, so, and go home and please finish the following for me. So you will be given that worksheet. I've just given some further elaboration on that. It is more advanced version, I must tell. I will give you this. I'll give you this as well. Something about the particle will point, what happened to this. Okay, and what you need to do is to finish them. Tell me the difference between the mixture and the compound. Okay, tell me the difference between them. And we would like to go back to this. Okay, indeed today we have just come up with the pure substance. We have got some, when you mix together, will form impure substance, right? So we call it mixture. So for example, iron sulfur mixture is just one of them. But if you want to get a pure substance, we have got two types. One is, if you do chemical decomposition, it can be further broken down. So what is that? On the left-hand side, this word. What is that? But we have chemical combination, they will form this. We start from word C. What is that? We call it compound. Pharma. Well, for this, what is that? It is elements. Elements. Okay? So, this is the whole logical thought, right? To tell you this. And we can, a human, we try our very best to separate that pure substance into compound and elements. But everything starts from what? Everything starts from impure substance, right? Impure substance, I separate into pure substance, but I further get to know what is that. Is compound or mixture, or a compound or elements, okay? So this is what you may know about this. And do you know that I've also got a YouTube channel? Do you know it?
Yes.
Yep, I've got a YouTube channel. So I would like to upload this video onto the YouTube channel as well. Okay, do you know my name?
Yes.
What is that?
Cam Chin Sir.
Yep. So you may find my channel name and you may go there, and I will just save the video there. Okay, questions? What do you think about today's lecture? Is it you find it difficult, challenging, or what?
如果同一樣嘅element， 同一樣嘅 ratio 咧，用唔同嘅 chemical 嘅方法嘅話，佢會唔會變做唔一樣嘅 mixture 同埋 compound 嘅？
The answer is yes. For example, if you want to produce calcium carbonate, as an example, limestone, right, marble, you may have calcium, carbon, and oxygen as the forming elements, right? Calcium, oxygen, and carbon. So in case I place that three together, so they would have their own way to combine. Okay, for example, calcium react with oxygen to form calcium oxide. Carbon and oxygen, they will combine to carbon monoxide or carbon dioxide. Okay, so they may have a chance of forming calcium carbonate. So it really depends on the experimental condition, and they will show different substances, or maybe a mixture, or maybe a combination, different combinations of different materials. So you may have a chance of having all those mentioned examples all together. So it really depends on the chemical situation, the experimental situation that you perform the experiments. Okay, good questions. Okay, it's different. 例如你想整碳酸鈣咁樣啦，即係你可以係咁，你原材料係鈣啦、碳同氧啊嘛，咁你放晒喺度嗰陣時咧，等佢 react， 唔同溫度咧，或者係同一個溫度都好啊，譬如一齊高溫啦，佢 form 嘅嘢咧可以唔一樣嘅。可以係氧化鈣啦，即係生石灰啦，一氧化碳、二氧化碳、石灰都有。咁所以就你要睇翻係個實驗情況，唔一定會 form 晒嗰隻你想要嘅嘢。咁尤其是幾時至會發覺有呢個複雜性咧？就係、如果你個 compound 咧入邊所形成嘅 element 咧嘅數量好多，譬如呢個係3隻嘅，咁你就會有機會有出亂子啦。2隻會唔會唔出亂子啊？其實都會㗎，例如係 carbon 同 oxygen。2個加熱，你會變咩？你可以變一氧化碳同埋二氧化碳嘅喎。咁我點樣去 control 咧？我點樣可以整到一氧化碳冇二氧化碳，或者調翻轉二氧化碳冇一氧化碳啊？嗱，二氧化碳我 make sure 全部二氧化碳係得嘅。例如係咩咧？多啲氧氣就得啦，多啲氧氣少啲碳就得啦。我嗌呢個咧叫完全燃燒。但係點整多啲一氧化碳咧？咁點整啊？缺氧咯，所以啲人燒炭咪就咁咯。閂埋啲窗，係咪啊？閂埋啲窗就咁燒炭咯。咁我咪製造一氧化碳多啲咯。咁但係製造過程有冇二氧化碳都係有，不過多啲一氧化碳啫。咁所以咧，完全地一氧化碳做唔做到啊？就係做唔到嘅，點都有二氧化碳。OK， 直至到啲冇晒氧，越嚟越少氧，咁就多啲一氧化碳，少啲二氧化碳。咁即係其實你要睇翻個情況而定咯，得唔得 ？OK， 做咩嘢問？冇咯，我哋下堂幾時見 ？Day 幾啊 ？Day 6 is it? Is it day 6? I forgot. So you see you guys on next lesson. Any questions? Okay, bye bye. Yep.
係day 6啊。
Yeah, day 6. Okay, see you guys. Bye bye.
Bye bye.